Hello, so we have a function, wonderful. What are all these k's doing in here? K just being a constant. In this case, they've told us it's a positive constant. And we're asked to use calculus, well, surprise, to find expressions in terms of k for the ranges of values of x for which this graph is increasing. Okay, so what will this graph even look like? I see that we have an x cubed, x squared, x, and a constant. So that is a cubic. I also see that the coefficient of x cubed is negative, right? Because k is positive, so negative 2 times a positive squared is still negative, which tells me that the cubic will look something like that, right? The function f of x. Do I know the exact values yet? No. But I know that it decreases to a minimum, increases to a maximum, and then decreases again. And we're trying to find the ranges of values of x for which it is increasing. So that will be this section right here, between the minimum and the maximum. So all as we need to do is find those x values, right, of the turning points. Because once we have those, we can say that x must be between those values. Alright, so how do we do that? Well, we know that the turning points have a gradient equal to 0. So if we have the gradient function, we could equate it to 0 and solve for x. So let's do that. So we know f of x. Let's find f prime of x, the gradient function. So looking at the first term, the power of x is 3, multiply it out the front to give minus 6. K squared is just a constant, so that stays as is, and then we subtract 1 from the power of x. So 3 becomes 2. Next term, power of 2, multiply out the front. So that's plus 6. Again, k is just a constant, so that stays as is. And x to the power of 1. Because 2 minus 1 gives 1. And then the derivative of 12x is 12, right? Because y equals 12x, for example, the gradient of that function is 12. It's the coefficient of x. And finally, the derivative of negative 55, the derivative of a constant, is 0, because its gradient is 0. So we don't need to write that. Awesome, so we have the gradient function, which tells us for a given input x, it tells us the gradient of the original function. Now, how we can use that is we know that we need to find the x values of the turning points, and then we know that turning points have a gradient equal to 0. Right, so I'm writing that as a line of working to show my understanding of that. So what we'll do is we'll set the gradient equal to 0. So we have 0 equals our gradient function. And now normally, if there was no k, right, this is quite easy. We just factorize or we solve using the quadratic formula to get the x values. However, this is an excellence question, and it's asking to leave our answer in terms of k, which is why we do need a bit of algebra, unfortunately, or fortunately, depends if you like algebra. So looking at this, few ways to go about it. From here, you could immediately use the quadratic formula, which will be a little bit of work, and will get a bit messy, but it will definitely work. I'm going to factorize it instead, because I find that a bit easier. Cool. So to do so, I firstly acknowledge the common factor of 6. So I'll divide everything by 6. Actually, I'll divide everything by minus 6 because I want the coefficient of x squared to be positive. So k squared, x squared. And instead of plus 6, it'll be minus kx. And then 12 divided by minus 6 is minus 2. So again, we did that on both sides. However, 0 divided by 6 is still 0. Which is why that's a great step to do. It just simplifies the problem. What next? So the k squared out the front makes it a little bit tricky. We could either do some trial and error. For example, use brackets, and we could have kx in each, or we could have a k squared x in one and an x in another. But let's have a think what would happen if we had a k squared and an x in one. We would get, looking at the middle term, it must be k to the power of 1x. So if we have a k squared x times a constant, we would get this k squared x term. However, we only want a kx term. So that means we can eliminate that option. And now we need to think of two numbers that multiply to -2 that will also result in negative kx when we expand it out. So I can think of either 1 and -2 or -2 and 1. Again, this is a little bit of guess and checking. So if we expanded both of these out, what would we get? Minus 2kx plus kx, that's looking good, because that would simplify to minus kx, whereas the other option would be plus 2kx minus kx, which is positive 1kx. So just doing that bit of side working, we have successfully factorized the quadratic. Cool. Alright, and again, once more, I do encourage you to try, actually from here, use the quadratic formula to find the solutions. So try that out. But we factorized it, so we know that either this equals 0 or this term equals 0. So kx plus 1 equals 0 or kx minus 2 equals 0. So solving for x, it would be -1 over k or 2 over k. Would be the two solutions. So again, using the quadratic formula, you will get the same answer. And if you don't, try again. Cool, so we've worked out the x values of the turning points. So now how do we put that into a final answer? So we would say, therefore, for f of x to be increasing, in other words, a positive gradient, x must lie between -1 over k and 2 over k. So remember, k is a positive number, so -1 over a positive number is still negative, whereas 2 over a positive is still positive, so the negative number on the left, the positive on the right. Would it include those points? So if it included those points, that means it includes the turning point, but the gradient of a turning point is 0. So it's non-decreasing, but it's not increasing. So we actually would not include those x values. Cool. But how do we justify this? How do we know that it's increasing between those values and not, for example, outside? So we could say this is because f of x is a negative cubic. See above diagram. Right? So for a negative cubic, it is increasing between the turning points. So in summary, we found the gradient function and we set it equal to 0 in order to find the turning points. So that is our achieved step. We then found the x values of the turning points by either using the quadratic formula, or if you're comfortable with factorizing, a bit of guess and checking and solving that way. So to find x equals -1 on k, or x equals 2 on k. And then finally, we stated the range of values for which the function is increasing, and we gave a justification. In this case, it was easy enough to justify it based off of the shape of f of x. However, you could have also considered the shape of the derivative, or you could check the gradient at an x value, let's say at 0, because that is in between those two values, and that would give us, when x is 0, the gradient would be positive, which means it's increasing. So that would also work. Yeah, but again, being comfortable with the shape of the graph will put you in a good place. All right, see ya.